A mass on a spring has been displaced 5 centimeters below the equilibrium point and released. The mass is vibrating with a frequency of 1/3 cycles per second. Write the equation of simple harmonic motion and graph 3 cycles of the displacement as a function of time. First of all, because we're starting here 5 centimeters below our equilibrium point, and then released, that's going to be a minimum point. And so if I were to maybe just look at a little graph here, we're starting at -5, okay, 5 centimeters below equilibrium. Then we release, and it's going to bounce up, okay, and do something like that, okay, back and forth. I'm going to go ahead and get rid of that for now. But because it starts at a minimum, that tells me that I'm going to be using a cosine function. So I have y equals a cosine of bt. A, I know, is going to give me the amplitude or maximum displacement from my equilibrium, which is here at 0. Because I'm starting at -5, I'm going to choose A to be -5. Now B, I determine based on my frequency. I have a frequency of 1/3 cycles per second. And we know that B over 2 pi is equal to the frequency, which in this case is our 1/3. Multiplying both sides by 2 pi gives us B equals 2 pi over 3. And so our function is y equals -5 cosine of 2 pi over 3 times t. Now for the graph, we want to graph 3 cycles. And because we have a frequency of 1/3 cycle per second, then we're going to have to go, we know that in 3 seconds we're going to have 1 cycle. So 1, 2, 3 will be 1 cycle. But then we want 3 cycles. So we'll have another one, 3, and another one, 1, 2, 3. So I'm going to have reach my minimum again here over at 3, -5, and then over at 6, and then over at 9. And my maximum, of course, will occur up at +5 and will be halfway between each of these points. Okay. So there's just a rough sketch of where my maxima and minima will be. And then we can go ahead and sketch. And of course, this is definitely not going to be perfect, but that gives us an idea of what's happening here.